Compound interest is the interest computed on the principal and also on the accumulated past interest. Is the interest added to the principal of an investment or a loan so that the added interest also earns from then on. This addition of interest to the principal is called compounding. In other terms, compound interest is interest on principal plus interest, which is added to the principal amount of a loan or deposit.
Compounding amount. It is the amount at the end of the term after several compounding. It is the sum of the original price or the principal and its compound interest. In other words, compounding amount is when the original principal amount is added to all interest accrued or accumulated and compounded to the particular date of calculation. To compute for the compound amount f, we use the formula f is equals to p times 1 plus r divided by n raised to n times t, where f is the maturity value or future value at the end of the term, p is the principal amount, r is the rate, n is the number of times the compounding occur in each year or period, and t is time that must be in years.
Compound interest formula, where compound interest is equals to maturity or future value minus the principal amount.
In the corresponding values of n, we must refer to the following period that is commonly used as the basis for compounding interests. If you are given the period annually, it means that the compounding occurs once each year, and the value of n is 1. Semi-annually means that compounding occurs 2 times each year. The value of n is 2. Quarterly means that compounding occurs 4 times each year, and the value of n is 4. Every 2 months means compounding occurs every 2 months, and the value of n is 6. Monthly, compounding occurs 12 times each year. The value of n is 12. And daily means that compounding occurs 365 times each year, and the value of n is 365.
There are other formulas that you have to be familiar with. These formulas were all derived from compound interest is equals to f, or known as maturity or future value, minus the principal amount. And f, or future value, is equals to principal multiplied by 1 plus rate over the number of times compounding occurs raised to the number of times the compounding multiplied by time. If we are solving for the p, or the principal amount, we would use the formula. P is equals to the f, or maturity value, over 1 plus rate over number of times the compounding occurs, raised to the number of n, number of times the compounding multiplied by time. Or P is equals to f, or the maturity value, over 1 plus r, or rate over n, or number of times the compounding occurs, raised to the negative number of n, or the number of times the compounding multiplied by t, or time. If we are solving for the rate, we should use the formula where r, or rate, is equals to the number of times compounding occurs multiplied by future value over principal raised to 1 over the number of times compounding occurs multiplied by time minus 1 multiplied by 100. If we are solving for the time, we should use the formula where t, or time, is equals to log f minus log p over the number of times compounding occurs multiplied by log and multiplied by 1 plus rate over the number of times compounding occurs.
Now, let's go to problem solving. Jopay wants to have 2 million pesos for retirement in 45 years. He invests in a mutual fund paying an average of 9.5% each year compounded quarterly. How much should he deposit into his mutual fund? So first, we must find what is asked or what is unknown. So, it is the amount that Jopay needs to deposit in his mutual fund. It is clear that the principal is the unknown value just by reading the word deposit. Next is we need to find the given values. So the given values are the future value, which is 2 million, time, which is 45 years, rate is equals to 9.5%, and when we divide it to 100 to get the decimal, we could get 0.095. The n is 4, since it is stated that it is compounded quarterly and the principal is unknown. Then we must use the formula of the principal to arrive at the answer. which is f over 1 plus rate divided by n raised to n times t. We can substitute these values to the formula in our scientific calculators to accurately and conveniently solve for the principal. After substituting these values, we can get this answer, and we must reduce it to the nearest hundreds. And the principal is 29,249.96 pesos. So now, let's complete this table by solving the unknown values. In the first row, the given are 10,000 pesos as the principal, 5% or 0.05 as rate, period as compounded quarterly so the n is equals to 4, and the missing values are the future value and the compound interest. To get the future value, we must use the formula f is equals to p times 1 plus r divided by n raised to n times t. Then, we can substitute the given values to the formula and encode it to our scientific calculator. Finally, we can get the future value of 11,607.55 pesos. Next, to get the compound interest, we must use the formula future value minus the principal. So, 11,607.55 pesos minus the principal of 10,000 pesos, we could get the compound interest of 1,607.55 pesos. In the next row, the given values are 10,000 as the principal, period as compounded monthly, so the n is equals to 12, future value of 11,614.72 pesos. The missing values are the interest rate and the compound interest. To solve for the interest rate, we must use the formula rate is equals to n times the quantity of f divided by p raised to 1 divided by n times t, minus 1 times 100. Then, we should substitute the given values to this formula and encode it to our scientific calculators. Finally, we can get the interest rate of 5%. Next, to calculate for the compound interest, we use the formula of future value minus the principal. So, 11,614.72 pesos minus the principal of 10,000, we can get the compound interest of 1,614.72 pesos.